Hi everyone, today we're going to be very destructive and do a small Mograph animation, and in this animation we're going to have this big sphere here which we're going to break into pieces as it gets hit by a smaller sphere, and this is what the animation will look like. So you can see the small sphere hits the bigger sphere, and then we're also going to have a bullet time effect using a free plugin called Magic Slow Motion by Nitro 4D. And we're also going to add a little bit of realism by using motion blur. Since we are going to use Mograph objects in this tutorial, you will need either Cinema 4D Broadcast or the studio version of Cinema 4D. I will post a link to the free plugin Magic Slow Motion by Nitro 4D, so make sure to check the video description for the link. And once you've downloaded the plugin, we can get started. First of all, I'm going to set up a basic scene by adding a floor object and a background object. And I'll move that floor down a little bit. That's just so I don't need to move any of the other objects that we're going to create later. So let's put this to about here, and I'm going to create a simple material, switch off reflectance, and for the color I'm going to change the model from Lambertian to Oranayer, make this a little more white, and I'll put this on the floor and on the background. Next I'm going to add a sphere, and I'll leave it at the default. The radius is 100 and we have 24 segments. We will probably need to increase that later because we need to bake the animation at the end, and when we do that our sphere will not render perfect anymore, but it will look a little bit faceted. But for now we're going to keep everything as it is. I will put this sphere into a Voronoi fracture object, and by default we get a couple of fragments which are colored. So with the Voronoi fracture object selected, I'm going to switch off colorize fragments, and let's go to the sources tab. I'm going to keep the point generator, but I want a lot more pieces. So I'm going to increase the point amount to about 300, and I want to change the distribution of the fragments because the other sphere is going to come in from here and hit this bigger sphere on this side here. So it probably makes sense to have more and smaller pieces on this side of that sphere. That will make things look a little more realistic, I think. So let's go ahead and change the distribution type to exponential, and now we get all of these options here. And what I want to change is the affection. I'm going to switch the x-axis affection off and turn the z-axis affection on, and you can see that if I switch off those points that we're getting a lot more pieces on this side here, so that's good. We could also put the y-axis affection to -y to move these up a little bit more, because the smaller sphere will be coming in from here and hitting that bigger sphere about here. And in order to make things look a little bit nicer when these pieces fall down and hit the floor, I'm going to use a different texture for the inside of those pieces. So let's go to the selections tab here and check inside faces. And this will create a selection tag that we can use to apply a different texture to the inside of the fragments. Let's go ahead and create another material. I'll rename this one to floor/background, and this one will be the inside texture, and I'll just use a simple color for that. Let's give it a nice blue maybe, and I'll drag it onto the Voronoi object and just drag the selection tag into the selection slot down here. I'm also going to rename this to static sphere. Copy that and rename the Voronoi object as well. And in order for this to be dynamic, we need to apply a simulation tag. So let's go ahead and add a rigid body tag to this. And if I hit play, the sphere will fall right through the floor, and that's because our floor needs a simulation tag as well. So let's add a collider body. And that's looking a little bit better. Of course, I don't want this simulation to start right away. So let's go back to frame 1. I'm also going to increase the frames to 120. And I'm doing 30 frames per second. So this will be a 4-second animation. In order to stop the sphere from falling down immediately, we need to select the dynamics tag, go to dynamics and switch the trigger from immediately to on collision. And that's all we need to do for now. So now we can go ahead and add a second sphere, which will be the smaller sphere. And this one I'll make 20 or 22 centimeters. And because I'm using the broadcast edition of Cinema 4D, I don't have real dynamics. So in order for me to make this sphere dynamic, I need to put it as a child of a Mograph object. And I'm going to use a cloner. And I only need one clone. And let's go ahead and move this over quite a bit. So move it to about here. I think in my original animation I did -750. And we also need to move this up a little bit to maybe about here. And let's add another simulation tag, a rigid body tag. And of course, if I hit play, it will just fall down. But I need it to move forward and hit the other sphere. So let's select the dynamics tag of this object here. And what I want to do here is change or switch on the custom initial velocity. And we need the sphere to move along the z-axis. So I'm going to change the speed here to 2000 centimeters. And now if I hit play, that smaller sphere is going to move and hit the bigger sphere. And that's not looking too bad for now, but there's some changes I want to make. For one thing, I want both of these spheres to have the appearance of being a little heavier. And we can again use the dynamics tag to make changes to the mass or density of the object. So for example, for the static sphere, we could change this to custom density, and let's do 10 or 12. And we could also change the mass or density of the smaller sphere. Let's use custom mass, and let's go for 2 or 3. Depending on what you use here, the dynamic simulation can look very different. So you just need to play around with these settings and find something that you're happy with. So let's see how that looks. And I think that is looking a little bit nicer because it's more dynamic and the objects seem to have real weight. What I don't like is what happens when all of these pieces fall to the floor. There is way too much bounce and not enough friction. So let's go ahead and select all of the dynamics tags, and let's go to collision, and I'll bring the bounce down to maybe 10 or 15. Let's try 10 for now. And I'm going to increase the friction to about 70 or 80. And I think that is looking a lot better. Let's add a new material for the smaller sphere. And for this one, I'm going to do a simple gradient. And I'll change that to 2dV. And let's copy this knot here. And I'll move this one inside. Well, let's move it over to here and make another copy and move that over to here. And I'm going to change black to a nice orange, maybe something like this. Let's copy this knot, delete this one, and now we just need to position these knots to place them where we need that stripe to be. So maybe let's move this over a little bit further, something like this. And I think I'm going to switch the interpolation to none and move all of these over to the left again a little bit. So something like this. And let's go ahead and put this on the small sphere, and I'll rename that to collision sphere Let's go back, hit play. Okay, and that's looking pretty good. What we could also do to change the look of the animation and make the calculation a little more accurate is we could go to Edit, Project Settings, or hit Ctrl D, and here we can go to the Dynamics tab, and on the Expert tab we could change the steps per frame and the iterations. Let's see what happens if we bring this up to 10. So I've just increased the steps, and let's see how that looks. You can see we're getting a pretty different look here, and I kind of like that because it's more violent. And maybe I'll move that smaller sphere down a little bit. Maybe even a little bit more, just to make it hit the smaller pieces more. Maybe something like this. And that's looking good, I think. And I'm just trying to find a nice camera position for the animation. So maybe let's do something like this. And now we can use that free plugin I mentioned at the beginning of the video, which is called Magic Slow Motion by Nitro 4D. So I'll add that to the scene. And we have a couple of settings for this plugin here. Let's see what happens if we just hit play. So you can see the slow motion starts around here, which is a little bit late. So we need to change the start frame and the stop frame, maybe play with the delay option here to get the look and feel that we want for the animation. And what I want is, as soon as this smaller sphere hits that bigger sphere, I want things to slow down a little bit. I also think the bigger sphere could be a little more dense, because I don't want the smaller sphere to go right into that sphere. Let's see if we can change that by changing the density for the bigger sphere here. Let's bring this up to 25 and see what happens. Okay, that's a lot better. Let's try 20. Okay, I think I like that. Now let's play with the settings for the Magic Slow Motion, because the bullet time effect starts way too late. So let's see what happens if we bring down the start frame to 15. I'm going to leave the stop frame as it is. So that's still a little bit too late. Let's try 12 and see what happens. could start a little bit sooner. So I think that's looking good. And I think it also could stop a little bit sooner. So let's try 45 frames. Let's play with the delay setting. I'm going to switch that to the minimum, which is the first frame here. And you can see we're getting a totally different look. And this is definitely not what I want. So we could try and move that start frame to 15. Change the delay to 2. Yeah. Let's do 17 for the start frame. It still doesn't feel quite right. Let's try 16. It's a bit tricky to get that to look right. Let's try 3. And I think that's looking a little better. Yeah, but it starts a little bit too late. Still a little bit too late. So this is looking good. Let's try 12 again and see what happens. Okay, let's bring that up to 50. Or maybe let's try 40. Okay, I think that looks okay. You can go ahead and play around with this a little bit more, but I think I'll call this finished. And before we render the animation, I also want to add a little bit of motion blur, because the smaller sphere comes in at a very high speed. If we render this, it just doesn't look as realistic. And in order to add motion blur to make things look a little bit more believable, we need to go to the render settings by hitting Ctrl B, and we need to switch the standard renderer to physical. And here under the physical renderer, I want to switch on motion blur. I'm going to leave everything else at the default now. So let's go ahead and see what happens. If I render this, nothing happens. So let's go ahead and render this to the picture viewer. And here we go. That is our motion blur effect. It looks a bit grainy, but you can change that by changing the quality settings for the physical renderer. And the sphere looks a little bit jagged, so I'll probably want to increase the segments for this. So let's go ahead and select the static sphere and change the segments to 48 maybe. And that's looking a lot better. I think at the beginning of the video I said the fact that the sphere looks jagged is because we need to bake the animation, but apparently that was not really true. I do think we need to bake the animation because while the motion blur is showing in a single frame, it's not going to show if we render an animation. Let's just go ahead and test that. I'm not quite sure. but let's go and find out. I'm going to change the frame range from current frame to, let's do 0 to 9 and see what happens. Okay, we can stop that. You can see we're getting the motion blur, so everything's fine. We don't need to bake the animation. We can leave everything as it is. The only thing you might want to change is the quality settings for the final render. So for the final render, I'm going to put this to HD 1920 by 1080. I'm going to switch that to all frames. And on the tab for the physical renderer, I'm going to change the quality, and my preferred setting is adaptive and automatic. And the reason I like this is because all I need to worry about is this window here. I don't need to worry about anti-aliasing, ambient occlusion, which I'm also going to switch on, because everything is controlled by the physical renderer here. So we just need to worry about this tab. And for the final render, I would probably bring this down to 10% and increase the blurriness to 4 or 5. And let's see, what else could we change? The ambient occlusion, because I'm using that. And we don't need to change the settings for the subsurface scattering. In fact, we can bring this down to 0. I don't think it matters, because if we don't have subsurface scattering, the physical renderer will not calculate it, no matter what you have entered here. Shadows, we don't really have any. We have the ambient occlusion, but just in case, I'm going to bring that up to maybe 4, and I'll just do a render for the current frame just to test this. And you can see with these settings, the motion blur is looking a lot better. If I go back to one of the previous frames, you can see we have a lot more grain here. So with a setting of 5 for the blurriness, for the ambient occlusion, we should be fine. You could also try to bring this down a little bit and save some render time. So if you can get the same quality with a lower setting, that's a good thing, because the render will go faster. So at 1280 by 720, a setting of 4 still looks alright. Okay, but for the final output, I'm going to crank this up to 1920 by 1080 and leave the settings that we just adjusted for the physical renderer, and we can render the animation. I'm not going to do that in this tutorial because it will take quite a while on my PC, and I already showed you the final animation at the beginning of this video. So this is the end of this tutorial. I hope you've enjoyed this video. Thanks for watching, and I'll see you again soon.